Here's an alternate way of looking at problem 3514. If we have a refracting surface, this is from chapter 36, and we have an object a certain distance p away from that surface, we can relate the refracting surface from an index of refraction of 1 to index refraction n2 as n1 over object distance p plus n2 over image distance q is equal to index n2 minus n1 over the radius of curvature of that surface. The radius of curvature is defined as being positive if it is on the same side as the outgoing ray. And in this case, that would be the case here as our outgoing ray there. So, using this and applying it to our fish problem, if we have a fish below the surface and the fish is the object, so our object distance is the depth, and we are the observer over here. In this case, the radius of curvature is going to be infinity. So the second term here is going to be 0, and we're going to just end up with n1 over p is equal to a negative n2 over q. Q is the image distance that we wish to find. So solving for q, we would have that q is equal to negative n2 over n1 times p. In this case, n1 is the water, 1.33, and n2 is the air, 1.00. So our image distance is going to equal a negative 1 over 1.33 times the object distance, which is actually the actual distance of the fish below the water. So this is going to be equal to 0.8 meters divided by 1.33 negative, and that will be a negative 0.6 meters, which is the answer we got in the last problem. The negative sign for the image means that it's not on the outgoing ray. In other words, if this is where the object is, where the fish is, and the image, normally the image is defined as positive if it's on the outgoing side of the ray, but the ray is coming to our eye like this, and the image is actually on the negative side of that interface. So our Q distance is this distance here, and it's not on the side of the outgoing ray, hence it's a negative image distance of 0.6 meters.